Hello, we continue our business statistics course. In this video, is it the first video? We continue chapter 1, Introduction to Business Statistics. And before the Lunar New Year, we already defined what statistics is. We already discussed some important definitions in statistics, such as population parameter, sample statistics, population mean, sample mean, population size, sample size, population standard deviation, sample standard deviation, population variance, sample variance, and population proportion and sample proportion. And I hope that you still remember all of these terms. So in order to illustrate the calculation of the population parameters and the sample statistics, let's do example 1.2. Suppose there are two villages, V1 and V2. Each has 5 people. The information is given as follows. So in village V1 we have 5 people, A, B, C, D, and E, with their monthly income in $1,000 and their ages. Village V2 has 5 people, F, G, H, I, and J, with their monthly income in $1,000 and their ages. In question A, calculates the mean and standard deviation of income of all the people living in village V1. Now we do question A in an Excel file. So in question A, we will calculate the mean and standard deviation of income of all people living in V1. Because we compute the mean and the standard deviations of the entire population, so in this case, we will calculate the population parameter. So first, calculate the population mean. So the symbol of the population mean is mu. Okay, so mu equals, you can use the function average in Excel to calculate the population mean. Okay, of 5 people, 1, 2, 3, 4, 5 people in village 1, and you hit enter. So the average income or the population mean of the income of all people living in village V1 is $1,400 per month. You can also calculate the population mean using the formula. Okay, so the population mean equals the sum of all the value in the population, sum of all the value in the population, 0.5 plus 1.5 plus 2 plus 1.5 plus 1.5, and divided by the size of the populations or the number of observations in the populations, and in this case the number of people, the total number of people in village V1. So you divide it by 5, hit enter, and you get the same results, $1,400 per month. Next, we calculate the standard deviation of the income of all the people living in village V1. So in this case, we will calculate the population standard deviation, because we refer to all the people living in village V1, and the symbol of population standard deviation is sigma. So sigma equals, you can use the function stdev dot p. Okay, we use stdev dot p because we compute the standard deviation based on the entire population. So if you want to compute the sample standard deviation, can use the function stdev.s, but in this case we use the functions .p because we calculate for the entire population. And you choose all the income values of the people living in village V1, and then you hit enter. So the standard deviation of income of all the people living in village V1 is $0.489,000. So remember that the unit of the standard deviation is the same as the unit of the mean population mean. Okay, so this is $0.489,000. We can also use the formula to calculate the population standard deviation. And we get the same result, $0.489,000. And question B is the same as question A. Now we calculate the population mean and the standard deviation of the people living in village V2. Okay, now we do the question B, and it's the same as question A. So first we calculate population mean. Use the average function on the incomes of all the people belonging to village V2, and we get the same amount of income, $1.4 thousand per month. And then we calculate the standard deviation of the entire population, standard village V2, and we can use the function stdev.p, and we also select all the values of incomes in village V2, and the standard deviation of the village V2 is $0.089,000 per month. Based on the standard deviation, we can say that the standard deviation of income of all people living in village V2 is smaller than village V1. So we can conclude that village V1 has more variation or has more dispersion of income than village V2. And now question D. Select a sample of 3 oldest people in V1 and calculate the variance of income. So this is a formula of sample variance. So we will compute the sample variance. In this case, we don't compute population variance because the questions ask to select a sample of 3 oldest people, not the entire population. We use the function var.s to calculate the sample variance, and we choose the incomes of 3 oldest people in village V1. So we can look at the age of each person. So person E is 77 years old, so we choose the income of person E, and we choose the income of person D also because the person D is also 77 years old, and we choose the income of person B because he or she is 71 years old. And then we hit enter, and we have 0 sample variance. Why? Because the income of all these people, B, D, and E, so they have the same income, $1.5 thousand per month. So there's no variance, no variations in their incomes. So the sample variance is 0 because no difference. And question E is the same as question D. We will calculate the sample variance of the income of the 3 oldest people living in village V2. We use the same function var.s to calculate the sample variance, and we choose the income of the 3 oldest people in village V2. So we choose the income of person G, person I, and person H. Okay, the 3 oldest people in village V2. So we have the sample variance of 0.013, and the sample variance is larger than 0 because we have fluctuations, we have variations in the income of the 3 oldest people. Okay, we have different values, not the same values. So in question D, we have the same value, so we have 0 sample variation. But in question E, we have different values, so we have positive sample variance. And the last 2 questions, F and G, we are asked to calculate the proportion of the people younger than 70 in the 2 villages. And this is the formula to calculate the proportion. And in this case, we will use the population proportion pi. And this is the formula to calculate pi, because we calculate the proportion of the people in the entire population, not in the sample. In this example, because the number of people is very small, only 5 people in each village, so you can count the number of people younger than 70 years old, and you can just calculate the proportion by simple calculations, such as there's 2 people in village V1 younger than 70 years old, so the proportion of them is simply 2 divided by 5 is 0.4 or 40%. But in case you have many people in each village, so counting by hand is very difficult and time consuming and is not accurate. So we can use the function countif and select the ages of all the people in village 1 with the criteria smaller than 70. And we have 2 people younger than 70 years old. And then we can calculate their proportion easily. 2 divided by 5 is exactly 0.4. It's all 40% of the people in village 1 younger than 70 years old. And question G is the same as question F. We calculate the proportion for the people in village 2 younger than 70 years old. Because there are only 5 people, so we can count 2 people in village 2 younger than 70 years old. And the proportion is 2 divided by 5, so we have 0.4. Or you can use the functions countif. We choose the ages of all the people in village 2, and the criteria is smaller than 70. So there are 2 people in village 2 younger than 70 years old, and the proportion is 2 divided by 5, you get 0.4 or 40%. In the example, each village has 5 people, so we can easily know the information and calculate the population parameters. In reality, however, a village can have thousands of people, and a city or a country can have millions of people, thus making it impossible to compute the population parameters. As a result, we can only draw a sample for the population and calculate the sample statistics. Now we do another example. We have 4 stocks A, B, C, and D, and the prices are given in the table. The unit of the stock price is $1,000. And question A. Calculate the sample mean and standard deviation of the prices by using the formulas as well as Excel. And question B. Calculate the sample variance of their prices by using the formulas as well as Excel. Stock prices are time series data. So in the example, the stock prices have time sequence. For example, the stock rise in January happened before the stock rise in February, and it happened before the stock rise in March. So we have the time sequence. It's different from the incomes of the people in the village V1 and V2 in the previous example, because in the previous example, the data is cross-sectional data, but in this example, the data is time series data, and we only have 6 observations of the stock prices in 6 months. So when you calculate the mean and standard deviation, so remember that when you have time series data and you have some observations, you always have a sample, not the population. Okay, now open Excel and we do the question A. So please remember, the symbol for the sample mean is X bar, and the symbol for the sample standard deviation is S. Okay, so you can use the function average in Excel to calculate the sample mean of stock A. So you choose on the stock prices in 6 months, and the average stock prices is $107,000. And we can use the functions standard deviation STDEV dot S, because in this case we want to compute the sample standard deviation, and you choose all the prices of stock A and you hit enter. So the standard deviation of stock A is $27,000. And you can use the formula to calculate the sample mean of stock A. Just sum on the stock prices and divide it by the number of observations divided by 6, so you get the same amount. And you can apply the formula to calculate the sample standard deviation. First, you compute all the difference, the square of the difference between each value and the sample mean, the square of the difference, and then you sum up on the square of the difference. Okay, so we sum up all the square of the differences and then we divide it by the number of observations minus 1. Please remember that we divide it by the number of observations minus 1 because we are computing the sample standard deviation or not the population standard deviation. So we have to divide it by 6 minus 1. And we have the same amount of sample standard deviation, 27.092. And the rest of this exercise is for your homework. So please do this example at home. You can do on laptop or you can do on smartphone using Excel apps or Google Spreadsheet app or use WPS Office app or other apps that have the same function as Excel. So this brings me to the end of my presentation today. So thank you and see you in the next video.